Hi guys, today's video is going to be all about careers in geoscience. So a while back I announced that I planned to make a video like this, but it wasn't until recently that I saw an article about geology departments closing that I really felt motivated to make this video. So I saw this article about universities worldwide shrinking or even closing their geology or geoscience or science departments. And I will link the article down below for you. But basically what this means is less funding for geological research, for geological teaching, and also just not enough future geoscientists to do everything the geoscientists need to do. And the irony in this that I feel like is really just unfortunate is that today is a day that we need geoscientists more so than we ever have. So what is the reason behind geology department shrinking? Well, students just aren't that interested in majoring in geology. And I think, as well as the people that wrote the article, also think that this is due to a misunderstanding around what geology means to those undergraduate students who are choosing their major. Many students misinterpret geology as limiting them to oil and gas or mining industries, and they don't think about all the possibilities within geoscience. It doesn't mean oil science, it doesn't mean rock science, it means earth science. And earth has a lot of things on it that we can study. And that brings me to this point that geologists study earth. It's just the definition of geology. So geologists here, I put study Earth's history, nature, materials, and processes. And that encompasses a lot, guys, basically everything. And as you've seen in some of my videos that are about geoscience, it's not even just Earth. We also study the geology of other planets and other moons. And that might sound weird because geo means Earth, but in their case, maybe it would be like Marsology or something like that. But we didn't feel like making a different name for every single planet and moon that we studied, so we still call it geology. So geology is not only limited to Earth, which is already a lot, but also other planets and moons. Just wanted to put that out there. And with that, I wanted to introduce this ultimate list that I came up with about the types of earth scientists or geoscientists and their specialties based on these types of scientists. And I am probably missing some, as well as some of these go hand in hand with each other. And some scientists might identify as more than one of these. I do, so I'll tell you about that. But basically, let me just walk through this list so you can first hear about all these different geoscientists, and then I will walk through a few major types of geoscientists and what they study, what they do, where they can work, how much they can make, and all of that. So this list contains, but is not limited to, economic and exploration geologists, who I believe for the most part use their knowledge of Earth to help find resources under the ground that can be economically valuable to us, and then help extract those resources and help us use them, and just all of the things that goes along with exploring for these resources and finding ways to use them economically. Then there's engineering geologists who use their knowledge of Earth and Earth materials to help with engineering projects. This is one of the types of geologists that we'll talk about later in more depth. There's also environmental, atmospheric, soil, and climate geoscientists. And I clumped these scientists together because there's a lot of overlap there. So I clumped these guys together, but they're also separate depending on what exactly they study and how they apply their knowledge. But that's a huge field, especially huge and up and coming, and it's very versatile. It can work in a variety of different settings. There's also geomorphologists and geophysicists who also overlap quite a bit, basically study the physics of Earth and the morphologies or shapes and structures that Earth creates and how that happens and how it might affect humans and natural hazards, and predicting those hazards. Is a fault going to slip? Should we worry about an earthquake? All these types of things, and a lot more that I don't know because I don't study that, but that's what I interpret that as. There's probably many other things that go under that. There's also mineralogists who study mineralogy, but that is also very versatile because, as you guys know from my mineralogy playlist, there are tons of different minerals. I even have 4 different songs listing off mineral names on my channel if you want to check those out. But that's 4 songs full of just me listing mineral names. So like, obviously there's a lot of freaking minerals that you could study, and many mineralogists focus on more than one. There are multiple minerals, and many focus on one mineral or one major group of minerals. And many do a more broad approach to mineralogy and study how mineralogy affects other fields fields of geoscience. And so there's just a lot of ways you can approach mineralogy, and it really is also applicable to material science. I mean, you guys know I've said this before, that what we don't get from growing things like plants, we get from mining, we get from the earth. So knowledge of mineralogical, physical, chemical, and biological components of earth materials and their physical properties and structures is really important for material science and technology. There's also volcanologists on this list. I will go over volcanologists in more detail on a different slide, so wait for that. There's also glacial and structural geologists. I got my red pointer out because I feel like this is just a long list. I should probably point where we are. Basically, glacial geologists study glaciers, which is a huge field of study because studying glaciers is really important, especially today with glaciers melting and everything. There's also structural geologists who study the structure of Earth. This overlaps often with geophysics and geomorphology, but they study the structures of Earth and how that applies to different fields. I'm not a structural geologist, so I don't know all the applications, but I already listed a couple when it came to geophysicists and geomorphologists. Then there's also petroleum geologists. This is kind of similar to economic and exploration geologists in terms of their research applying to petroleum geology, which is, oil, gas, fossil fuels, and how they're transported, how they're preserved, just their geological properties, so that those exploration geologists can go and explore and find those resources. And then there's also petrologists who study rocks. A lot of people think geology means petrology. They think that geology is the study of rocks, but petrology is actually the study of rocks. And I'm sure you know this if you follow my other videos. I have a whole metamorphic petrology playlist and igneous petrology playlist. That means the study of igneous rocks or the study of metamorphic rocks. And then there's also sedimentologists who study sedimentary rocks and processes. And there's also hydrogeologists and hydrologists. I'll talk about that one in a later slide, so hold on to that. And then there's geochronologists who date rocks and date sediment and help to constrain ages of strata so that our research can actually have meaning, especially when we're trying to reconstruct ancient conditions on Earth, because I do a lot of this, and without ages, it really has no meaning. Paleontologist is one that we will go over later in more detail. Geochemist is just what it sounds like. It's studying the chemical processes of Earth and the chemical composition of Earth's rocks, the composition, the isotopic composition. You guys know I talk a lot about isotopes on my channel here, and a lot of that work, or all that work, is done by isotope geochemists. Biogeochemist, you guys know I have biogeochemistry videos as well, because that is a lot of what I study as well, because I study kind of that intersection between geology, biology, and chemistry, how microbes and the ambient chemistry of the ocean affect sedimentation in the ocean and precipitates, chemical precipitates that might form, and how those might help us reconstruct paleoclimate and paleoceanography. So again, fields overlap a lot. Then geomicrobiologists, I have a whole playlist about geomicrobiology on my channel, so you guys know that's a huge thing that I also look into. But it's basically how microbiology affects geology and geological processes on Earth, as well as other planets and moons. And meteorologists is another one we'll talk about on a later slide. Oceanographers is another one we'll talk on a later slide about. And then again, I list here astrobiologists and more, because astrobiology is something I talk about as well on my channel, and I mentioned earlier in the video. And then also I put and more because I know I'm probably missing some. So if you guys do a different field, or maybe you overlap with one of these fields, but you really identify as something else as a geoscientist, please let me know in the comments, because we all want to know. We want a complete list. So let me know. But that's the list that I came up with. And again, I mentioned here, these are not mutually exclusive. They overlap with each other a lot, which is great because we also need collaboration amongst scientists. But even as an individual scientist, you can overlap with multiple of these fields. For example, I identify as a geochemist, a biogeochemist, sometimes a geomicrobiologist, but not at the moment because my bacteria are really not behaving in the lab right now. Also as an oceanographer, specifically a paleoceanographer, because I study how to reconstruct paleoceanography, meaning the past ocean conditions throughout times in Earth's history, which is also overlapping with paleoclimatology, which is actually something I forgot to list here, but it's another field that's important. It kind of overlaps with climate science, although it's towards paleoclimate science. So anyway, you can see how these can overlap with each other, even if you're just one individual scientist. So now I'm going to take 8 of these fields or geoscientist careers and go over them in a little bit more detail, one by one, what they do, where they work, what degrees you need to do that thing, and all of the above. So let's get into it. First, we'll start with the people who identify as geologists, which is fine. I mean, you don't have to pick a very specific field to call yourself. You can just call yourself a geologist if you study Earth and its things. So where do they work and what do they do? Geologists can work at schools, colleges, and universities, teaching and or doing research. They can also work at government agencies to investigate, plan, and evaluate excavations, construction sites, natural disaster preparedness, and natural resources. And government agencies, guys, can include federal government agencies, state government agencies, local government agencies, and these can include the USGS, the U.S. Geological Survey, which is part of the Department of Interior of the federal government. This can also include parts of the Department of Energy, like PNNL, the Pacific Northwest National Laboratories, or ORNL, the Oak Ridge National Laboratories. This can also include NASA. This can also include local research institutions like the Woods Hole Oceanographic Institution, and also things like NOAA, the National Oceanic and Atmospheric Association. And so these are just the ones that I list off based on my experience and what I've wanted to do in my future, but there are a lot more I'm sure I'm missing. But for geologists, if you, depending on what you do in terms of geology, what you focus on, any one of these institutions could work for you. And then also private companies might hire geologists to locate natural resources like oil, gas, and minerals, evaluate environmental impacts, and comply with government regulations, etc. So it just depends on what you focus on that a private company might ask you to do. And then what degree do you need? Again, this really depends on what your goal is. For example, if your goal is to work in a university to either teach or do research, then you definitely need more than a bachelor's degree. You need a graduate degree. For a university specifically, probably a PhD degree. For a community college, you might only need a master's. For teaching in a high school, you would probably, I think, only need a bachelor's, but it really is kind of case to case depending on what your goal is. Government agencies, I know people that work at the USGS that only have a master's, that obviously that can limit how far up you go in the totem pole and how much you can end up making. If you do have a PhD, you can go a little bit higher and make more in the long run, but you can also start working there and then continue on to get your graduate degree and potentially your PhD while you work there. They can even fund it. I've seen that. So it just depends. Next, paleontologists. Paleontologists and paleobiologists study the history of life on Earth through the fossil record. And I'm not just talking dinosaurs here. Fossils can include body fossils like dinosaurs or even down to invertebrates like trilobites or something. And I've talked about invertebrate paleontology in a whole playlist on my channel. If you want to check it out, I'll link it up here. But they also include things like trace fossils. Trace fossils are, like footprints of dinosaurs or trails that organisms leave behind, burrows, bioturbation, these things left behind or structures left behind by animals that aren't the animal's body or organism's body. Those are trace fossils. But fossils can also include just pure biochemical signatures in the rock record that are indicative of biology having caused those chemical signatures. So what I mean by this is, for example, carbon isotopes in the rock record. Sometimes carbon isotopes preserve a light signature that was once caused by photosynthesizing organisms. If you want to know more about this, I talk about that in my carbon isotopes video, or I'll link it up here if you want to check it out. But biochemical signatures can also count as fossils sometimes if they do indicate biological activity. And with that said, you can see that, being a paleontologist can vary widely. Here I list some of the courses you might need to take to become a paleontologist, because I think looking at a course list can sometimes help with understanding what that field obtains and what you could do variety-wise within paleontology. For example, you could take paleobotany, which is, studying ancient plants and their evolution through the fossil record, as well as invertebrate paleontology. Again, I have that playlist on my channel about invertebrate paleontology. There's also vertebrate paleontology, which would include your dinosaurs and all that. And then also evolutionary biology. You can learn a lot about evolutionary biology by studying the fossil record. And where do paleontologists work, and what exactly do they do at those different jobs? Well, again, they can work at universities just like geologists could to teach and or do research. They can also work at museums in which they can prepare and care for fossil collections. This is one of those jobs that might not require such a high degree if you're looking to do something with potentially only a bachelor's degree. They can also work for oil companies and or state and federal government agencies looking for fossil identification for example, biostratigraphy, which is creating a stratigraphic column based on fossils, because sometimes, a lot of times, we have sedimentary strata that can't be dated using isotopes. And so we have to look for really specific index fossils, fossils that indicate a specific time period throughout Earth's history, and also regional mapping projects and more. And here I say that you need a graduate degree. Again, this really depends on your situation, guys. Again, if you're working at a university or want to go for teaching at a university, being a professor and or doing research, you definitely need a PhD degree in any case, whether you're a geologist, paleontologist, or any of the jobs we talk about, you need a PhD in that case. But if you're going for community college or high school or less younger than that, then you might not need that high of a degree. And then for oil companies, I would guess you would only need a master's, because that's typically what I have heard of people going into oil companies, but that I think also kind of changes and depends on what you focus on, what you're going for, what kind of job you're going for at that company. So I say here graduate degree, that could be master's, PhD, just depending on what you're going for. Next, seismologists. Seismologists study earthquakes and the waves that they cause to figure out Earth's structure and composition. So this also includes, I list here paleoseismologists and cryoseismologists, because I mean, seismologist includes all of those in there, but I want to be clear that you don't have to just study this on modern Earth or just on rocks. You can also study paleoseismology, so looking at fault lines throughout Earth's history and determining when earthquakes might occur in a certain area and how much slip that earthquake had to predict future potential slip on that fault line, just natural hazard, preparedness, all of that. And also you can study cryoseismology, which is like ice seismology. I believe, guys, I don't focus on these fields, so I don't know for sure, but that's what I'm guessing it is, which sounds really cool to me, like ice quakes. I mean, how cool is that? Where do seismologists work and what do they do at those institutions? Well, again, universities, they can work at universities to teach and or do research. They can also work at oil companies and or state and federal government agencies, again, to collect and interpret seismic data to find natural resources such as oil or water, or plan for construction projects. And again, the natural hazards and preparedness thing isn't listed here, but again, that's a huge thing as well. But then the degrees needed, a graduate degree is typically needed to do seismology, especially PhD for university, like all the other cases. And then maybe a master's, depending on if you want to go into an oil company or a government agency. I would say for a government agency, again, if you want to climb the totem pole as high as you can go, you're probably going to need a PhD, but you know, it depends on your case and who you know. Networking is really important in every field and not just geological fields, but yeah, that plays a big role. Next, meteorology. What do meteorologists do? Well, they study and forecast the weather using science, special instruments, and computer models. And meteorologist predictions, guys, can save lives and property. So where do they work? What do they do? Again, universities, they can teach and or do research. Oil companies and or state and federal government agencies. This one, I put a specific example, NOAA, the National Oceanic and Atmospheric Association, because that is really big for meteorology. They obviously do a lot surrounding both weather and climate. Weather and climate are not the same thing, but they do a lot of research with both of those, and you could do research and development for NOAA or another agency like NOAA. And then also television and radio. This is probably where you know meteorologists best. Basically, they can report weather on these television and radio stations, but again, that's not the only thing that meteorologists can do. They They work a lot behind the scenes to do the research and development as well. And also airports. I was actually surprised that the source I'm using to make this video, by the way, is going to be linked in my description. But when I was reading about it, they listed airports for meteorologists, and I was like, airports? But it makes total sense. Basically, they said that they provide weather info for flight dispatchers and pilots, which makes total sense because that's really important when you're flying through that weather, or might be flying through that weather. And, have you ever had a flight delayed because of weather? Well, those meteorologists are telling the pilots and the flight dispatchers, don't dispatch this flight. And because of those meteorologists, they save lives that way. So that's really important. And airports is also another option. And then what degrees do you need? This, again, guys, is case by case. But in most cases, a graduate degree is needed. I would say that I would guess that a master's would be okay for most of the list here, except for university being a research scientist. But yeah, check before you go into that field thinking you only need a master's. Next, volcanologists. Volcanologists study and monitor the Earth's volcanoes in all stages of activity all over the planet. Again, volcanologists can work at universities to teach and or do research, and they can also work at government agencies. I list here specifically the U.S. Geological Survey, as well as other state geological surveys. The USGS, guys, is only one geological survey that is just national. If you also want to work at a geological survey but can't find something at the USGS, there's also state geological surveys. These geological surveys can hire volcanologists to do research and field work like this dude over here, and hazard assessment. This goes back to natural hazard assessment, preparedness, predictions, all of that. Saving lives, guys. Geoscientists save lives. What degrees do you need to be a volcanologist? Graduate degree is pretty much a necessity here. You need at least a master's to work at either of these options, and definitely a PhD to go the university route. Next, hydrogeologists or hydrologists, who study the distribution, circulation, and properties of water to monitor, manage, and protect this fundamental resource. So water obviously is a really important resource for us as well as all living things on Earth, and it covers, I think, like 70% of Earth's surface. If I'm wrong about that, it covers most of Earth's surface. That's what I know. And hydrologists can work at universities to teach and or do research. You'll see this as a common theme throughout this video, and also federal, state, and local government agencies to do research and water resource development, management, and environmental protection, basically as listed up here. And also they can work at private firms for the same thing, development, management, and also the usage of water, because that's really important for protecting our resource and using it correctly and preserving it so that we have it in the future. And this is becoming even more important with climate change and sea level rise, and just, taking the salt out of salty water to make it fresh water is just not right now economically viable. So like understanding how we should use, allocate, and preserve water, as well as, understanding groundwater resources and like preserving those, and all of these, the study of water and hydrology and hydrogeology is just really important. The degrees you need for such a job would be a bachelor's degree in some cases, potentially for private firms, a bachelor's would be fine, at least to start. And also for federal, state, and local government agencies, I'm sure bachelor's would also be fine to start. But again, in those agencies, you would probably need a master's and maybe even a PhD to get further. Then universities, obviously PhD. Next, oceanographers. Oceanographers study Earth's oceans and seas and their contents and surrounding environments. There are a variety of different ways that you can study oceanography. For example, there's geological oceanography. You can study the structure, formation, evolution, and history of the seafloor. There's chemical oceanography, in which you can study the composition of seawater and how to extract certain chemicals from the seawater and the effects of pollutants on seawater, and also the biology that lives in the seawater, and that goes into biological oceanography we'll get to in a second. There's also physical oceanographers that study waves, tides, currents, transmission of a light and sound in the ocean, and ocean and atmosphere relationships. I actually saw a talk not long ago about somebody studying the transmission of sound in the ocean, and I didn't realize how different water is than air. Obviously, that sounds really stupid, like obviously it's really different, but apparently there are just a lot of challenges that go into the transmission of sound and light and everything through water rather than air that, is really important, technologically for our, submarines and things we send down to deep in the ocean to do exploration. It's just really different down there, and a lot of challenges that need to be solved. So like if you're interested in physical oceanography or studying these types of things, I would say it's a really, really cool and interesting field to go into. There's also biological oceanography, which kind of overlaps or is synonymous with marine biology. Basically, they study marine life and their relationships to each other, as well as the environment, how the marine life affects its oceanic environment. And I'm a little sad that they didn't list the type of oceanography that I do on this website, but basically I study paleoceanography, like I mentioned earlier. Paleoceanography, again, just like I mentioned with seismology versus paleoseismology, is just looking at how the ocean has evolved throughout Earth's history and what this means for our future ocean conditions and climate conditions, because the ocean heavily affects climate and all of that on Earth. So just all of the things. So where do oceanographers work and what do they do? They can work at universities to teach and or do research. They can work at government agencies to do research and development. They can work at private firms to search for valuable seafloor deposits, investigate areas for sea farming, and evaluate natural energy production from waves, currents, and tides, and just so much more, guys. So there are a lot of things that oceanographers can do at different institutions, and specifically the Woods Hole Oceanographic Institution is a big oceanography research institution that I've done work at before. I actually still work with the people there, but I don't work at that institution because I am still a student, but I am working with scientists who work there, which is awesome. I love it there. And the degrees you need, a bachelor's degree can be a starting place to go. I mean, obviously I've worked at Woods Hole and I only have a bachelor's. I'm currently a PhD student. And so technically my highest degree is the bachelor's because I'm going straight from bachelor's to PhD. But typically, if you want to have a full-time position at an institution like this, you definitely need a master's or PhD. I do know people there that do just have their master's, but they're not doing research. They're more so like lab technicians. But if you want to do the research part, you definitely need a PhD. And the last specific job description for geologists that I will talk about is engineering geologists or geotechnical engineers. And they basically use their knowledge of earth materials like soil, rock, and other materials to help plan, develop, and manage engineering projects. For example, they study the land surrounding building projects to determine whether a project is viable, safe, and what the appropriate building methods moving forward are. They also work on projects such as drilling wells, locating and extracting underground substances and resources, and studying the flow of water. And where do they work? What do they do? Again, they can work at universities to teach and or do research. They can also work at federal, state, and local government agencies and or private firms to do project development and management. This job, however, I would say from what I actually started as an engineering major, and from what I was told, you typically only need a master's degree if you are going to work as an engineer for a company or agency or private firm or whatever. I would say you hardly ever need a PhD in that case, unless you're going to work at a university and teach and do research at a university. So now getting into probably what a lot of you guys are going to skip to in this video, how much do geoscientists make? So the Bureau of Labor Statistics reports as of 2020 that the median salary for geoscientists is around $93,600 annually, which is around $45 per hour. Now, I did see other websites that were reporting around $100,000. I saw one that was 103, 106, average, median, all of these things. So it kind of hovers around that 100,000 mark annually. But I do want to note here that there are outliers that likely skew the number here. And this is not representative of a starting salary. When you're starting as a geoscientist, I know people that typically start around $25 to $30 an hour, which is still really high compared to what I make as a graduate student, as a research assistant. But yeah, starting salary, it really depends on what degree you have. But I do know people that just had a bachelor's that started at $25 an hour. And again, with experience, which I think is what most industry jobs would care about, you can make a lot more as you gain experience. The Bureau of Labor Statistics also predicts about a 7% increase in employment of geoscientists from 2020 to 2030, basically in the next decade, which is really exciting. But again, as we started this video with the sad news that many students are not choosing to do geology, there will likely not be enough students to fill those positions. So that's really unfortunate. And I hope this video excites you guys to go into a geoscience field, because Earth has a lot to offer, guys. It's so freaking cool. And it's not just oil and gas and mining. It is so much more than that. Environmental science, climate science, and even oil companies themselves are moving toward having huge departments dedicated to, clean energies, renewable energies, and all of these things. And I think that students should hopefully be aware of that by now so that they're not veering away from geology as a major, because it is the study of Earth. We need geoscientists more than ever. And the last thing I kind of wanted to end with, guys, is a little bit of a joke, but kind of not a joke. I wanted to list YouTuber here because obviously, as you can see, with my careers in academia, my careers in research, my careers in biogeochemistry and paleoceanography, and I don't know, maybe other things as I graduate and do different research projects, but I'm also a YouTuber, and YouTube at the moment does not make me a lot of money, but I wanted to mention this because there are, I think, really, really great science YouTubers out there. I mean, there's like Veritasium Physics Girl, or, Dr. Becky, who does have a job as an astrophysicist, but also does YouTube. And this doesn't have to be a full-time thing. It can be a side thing, which obviously we don't have that much time as we're doing research and other things. But with whatever time we do have, it's a great hobby. And I think, for me at least, it fulfills a huge desire of mine to reach more people with teaching, because I do love teaching. Obviously, you kind of have to like teaching to do this kind of thing, but it fulfills that huge desire of mine to reach more people with teaching and with my research, because if I left it as is, I would not have reached that many people through just publishing papers to journals that the 10 authors that also published papers on that topic would read, and then I would read their work, and then it would go back to them, and so on and so on. And it's this tiny little loop of your niche community of scientists that doesn't ever break out and reach the public unless it's like a breakthrough in science, which often doesn't happen with a lot of papers because it's just, not everything's a huge breakthrough, which is fine, but I really wanted to reach more people. So if you are interested in any of these fields, consider also doing YouTube, or even fully trying to do YouTube, but know that it's a long experience that might not pay off as much as you think, but it does pay off in terms of increasing your reach and communicating your science, which I think is really just super important. So that's all I have to say for this video. I hope you enjoyed it. And if you have any other careers in geoscience that I didn't mention that you want to bring to light to people watching this video, please comment them down below. I'm very curious because, again, guys, I don't study all of these things, so I don't fully know what they do. Even before I did graduate school, I had no idea that, paleontology could include things like biochemical signatures. So please comment down below your experience in any of these fields if you have it, or if you have questions for me regarding any of these fields, I can try and answer. But again, no promises, because I'm not an expert. I just wanted to share this because I've gotten this video request so many times, and geology departments are closing, guys. So go major in geology, please. Okay, bye guys. I'll see you guys in the next video.